Welcome to PGSMaths. In this video I will be looking at reflection and symmetry. Now, when looking at a reflection, there are two things to remember. The first is that the image is always the same distance from the mirror as the object. The object being the thing that is being reflected, the image being what would show up in the mirror or the reflection. Second thing to remember is that the reflection is always at 90 degrees to the mirror. I can quickly show this by drawing a line from the boy's finger to the mirror. Now if we continue this at 90 degrees, it hits his other finger. This distance to the mirror is exactly the same as from the mirror to the image. But how does that apply to mathematics? So let's have a look at this shape. We're going to try reflecting this on the line. Now we have to remember that everything is at 90 degrees, so we can just follow the straight lines until it hits the mirror line. The best way to reflect is to consider each point and reflect that individually and then join them up afterwards. So we'll start with this top left point, which I'm going to call A. Now if we go straight towards the mirror line, we go 1, 2, 3 squares, which means that the image is reflected 1, 2, 3 squares on the other side. It stayed in line at 90 degrees and is exactly the same distance. So let's try that for the bottom left corner. I'm going to call this one point B. Where do you think it goes? Well, we know that it's directly in line with point A here, so the reflection should also be directly in line. It's a test so that when we do reflect this at 90 degrees, we should notice that same pattern. So we count the line 1, 2, 3 squares to the mirror. So 1, 2, 3 squares for point B. Is this in line? Well, yes. So that's a good reflection. Now the third point is actually on the other side of the mirror line. But does this mean that we shouldn't reflect it? Of course not. You should always make sure that if you've been asked to reflect something, that everything is reflected. So if we call this point C, we can see that this is 1 square away from the mirror, therefore should be reflected to the other side, which is here, which is still 90 degrees, 1 square away from the mirror line, and that would be our finished point. To complete our shape, all we have to do is join together each of the lines. So we can go from A to C, A to B, and B to C. Does this still apply when we deal with a diagonal line? Well, the problem here is that most people will continue to try following the lines. Biggest mistake would be to take this point here, which we'll call point A, say it's 1 square away from the line, and then reflect it over here. If we did that for every point, we would soon begin to see that our shape would become massively distorted and look nothing like the original. So it can be very quick to tell if you've reflected something correctly, because the shape should not change. So what should we do this time? Well, remember we said you had to go at 90 degrees to the mirror line. So that means that we go diagonally down and right towards the mirror, which means our reflection is continuing along that line diagonally. Therefore point A would actually be reflected over here. Let's try the same thing with this point here. Where do you think this one goes? Do I follow the line? No. We go 90 degrees towards the mirror, straight and as close as we can. So this goes 1.5 to the mirror, so we go 1/2 and 1 to the other side. This usually baffles a few people, but just follow the rules, and an easy way to do this would be, if you were doing it on paper, just to turn your paper around so the mirror line is pointing straight down your page. How about if we have a point which is on the line? Well, that one's really easy. It's got 0 distance to the mirror, therefore does not have to be reflected. That could be our point C on both the object and on the image. Continuing this shape on, point D, E and F, and not forgetting the final point here, which everything has to be connected to, we should start to see a pattern emerging to complete the shape. 1, 2.5 to the line, 1/2, 1, 2 gives me point D. And if I join these ones up, so C is joined to A is joined to B is joined to D, should start to see it's like the shape has been rotated almost. Be careful, it hasn't. This is still a reflection, but it is facing a different direction almost. This line D to E, however, is parallel to the mirror line. It's in the same direction, therefore our reflection will also be in the same direction. We could use that to try and complete this part of the diagram. Should be 2 diagonal squares across, in line with the mirror. 1, 2. Does that still match? Well, let's have a look. 1, 2.5 to the mirror, 1/2, 1, 2 to point E. You don't have to always reflect every point. Once you realise what the shape should look like, you should be able to complete it quite nicely. Can you work out where point F would go? There are 2 ways of doing this. One would be to follow at 90 degrees to the mirror line. The other one would be to realise that because we have this L shape, that E and G both meet on the horizontal and vertical. So if I draw a vertical line from G instead of horizontal, and a horizontal line from E, we would complete our reflected shape. This is still at 90 degrees, the same distance on the other side of the mirror line, and therefore that would be our completed shape. Today's challenge involves an X and Y axes. Reflect the arrow on the Y axis and then the X axis. What happens to it? Can you describe that transformation in 1 step instead of 2? Have a go and leave your answers in the comment section below. Subscribe for future videos, send us any messages about what you need to know, what you'd like to know, or any comments about this video or any others that we've made at PGSMaths on Twitter or on Facebook /PGSMaths.